G'day guys. You're looking at Litz wire. A big roll of Litz wire. When I say big, I mean big. There, I'll put my hand on it. It's a big roll of Litz wire. This Litz wire looks like a lot there, but I have 600 kilos of it. And the reason being is that I was going to make coils. At one stage, I made really, really good coils. I made them for myself and a few other people. Very tight knit group of prospectors. And we did some tests with the coils. We did it with, I better not mention names, but yeah, because it causes conflict. That's the trouble. But yeah, somewhere around the central Victoria area. Okay, and we did some tests against the coils I made and the coils that were currently on the market, and everyone was of the opinion that the coils I made creamed the rest of them. And it wasn't just sensitivity, it was actually how much noise the coils generated in the hot sun. They actually didn't generate as much noise. Now work that one out. I know why, but I'm not going to say. Okay, this stuff, some of this stuff is really proprietary information that if I went blah, 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 well, you'd have every bloody coil manufacturer doing it and I get nothing out of it. So no, you're not going to know. Anyway, sorry. Some people might have an inkling of what I do to keep the noise out of it, but other people don't. But yeah, this is really good Litz wire. It is, I'll tell you what it is written on top of it. It is, from memory, the strand size is 0.125 millimeter, and there's 72 of them, 72 strands of 0.125, and that's basically what Minelab used on all their coils. That gives a resistance on your coil, on a coil winding, probably about 0.35, 0.4 of an ohm. And when you connect it up with your cable, it's probably running, 0.4, 0.45. The Minelab spec is really half an ohm, and around there, a little bit under. The lower the ohmage, the more power you're going to get, but the detector won't really deliver it. It'll start going to a current limit. It can't pump out endless amps. It also has series resistors and so forth in the detector as well, which negate the effect of having super low impedances. You can't make a 0.1 ohm coil and stick it on a GP or GPX or SD or whatever. It won't work. So you want to aim for about 0.3, 0.5. I've used coils all over the place. I've used things from 0.3 all the way up to probably 0.8 of an ohm, and they all work fine. Yeah, but anyway, I've got 600. What I'm going to tell you is I've got 600 kilos of it, right? So I might put it this up on the website on my detectormods.com website. We can roll it off, and yeah, you guys who want to make coils, we can sell this cheap, a lot cheaper than it cost me a fortune when I bought it. But and copper's gone up a lot since then. Okay, so that's a lot of money, but I can sell it a lot cheaper than you can buy it on eBay, places like that. I haven't advertised it. I did have it advertised at one stage, and then I didn't advertise it. I can't remember why. We took a lot of stuff off the website because it was just too fiddly and too much mucking around. Because really, when you start reeling off this stuff, you need another spool to put it on. I don't have spools, so I just don't have any. But if I just do it as a circle, wind it onto a former, and then I can, just tape it in the middle and, have it like a figure-8 shape, it's okay. You take it off at the other end and you can, wind it onto your own former or just wind a coil directly with it. Yeah, so, yeah, just keep in note, there's 600 kilos of this stuff, and it's top-notch for making coils. If you're making double D coils and you have a look at it, a lot of the double D windings are very thin. Some of them are not even Litz wire, I've noticed. And, if you make a double D and you make the transmit coil, God, dry throat again. Yeah, I haven't had anything to drink since I was outside, that's why. Yeah, if you make a double D coil or a concentric out of, or something like that out of this Litz wire and make both coils out of the same material, it works really well. Some of the coils I've seen used on the receive side being a couple of ohms, or even higher. I've seen them, probably as high as about 7 ohms. But keep it nice and low, keep your losses low, and, your receiver will thank you as well. Actually, your target response will be better as well. So, what else has been happening? A lot of things. Like, at the moment, I'm inundated with detectors everywhere. I mean, they're on the bench. They're down there. They're down there in boxes. They're over there. So I've been doing a lot of repairs and modifications on detectors. As soon as the sun comes out, everyone wants to go detecting. So just got in-rushed with a massive workload. There's a lot of stuff coming. Still waiting on stuff from the US to roll up before Christmas. I don't know if that's going to happen. But yeah, we've been very busy. Yeah, doing experiments here with an old SD2000 as well. This thing was destroyed and I've resurrected it. And yeah, you can have a look in there. It smoked the whole input stage there. A long time ago, I had to replace it. Even took out the 4093 driving the MOSFETs. Yeah, I put a shielded inductor in there just as a look at that. That's very temporary. But there's a shielded inductor there because the other one radiated noise. The original ones, they're an open bobbin type thing, and they're noisy. Replaced a couple of capacitors there, dried out. What else have I done to it? Oh, yeah, stuck a 3.2 megahertz crystal in there to clock it a bit faster. Readjusted all the potentiometers to remove earth field, get the timings right. And, dear me, can't lose my voice. Yeah, had to repair the power supply. That's why that transistor's stuck on the back of the board there. And you can see that the two old MOSFETs, whatever they were, God, I haven't looked at them for, God, the numbers on them for about 15 years. ZVN something, 2N something, I don't know. 210 something. Oh God, I can't remember the numbers. Anyway, I put some new modern stuff in there as well. So I've gone from series input resistance of about 20 ohms down to about 4 or 5, whatever. That's a the first one there's a 2SK1334, which are now obsolete, would you believe? And they're in all the Minelab GPXs. So if you see some, you better pick some up. And the other there is just a 2N7002. Yeah, just these MOSFETs are low capacitance and low on resistance. Well, the first one's 200 volt rated, the big one, and the other ones I think it's about 60 or something or 30. It's not critical. It's it's not seeing that much come past that transistor. Even transients are probably next to non-existent, and there's diode protection around it too. But yeah, it makes a big improvement. I've actually changed the filter capacitors on each channel. Normally they're 10 nanofarads. I stuck 36 in there. But I said I'm playing around, and I'm just seeing what I can get away with by clocking the credoodles out of it. And when I go back into low frequency mode, I'll probably put a 1 meg crystal in there and clock the whole thing a lot slower. And those capacitors will improve the performance when you start dropping the frequency and, you know, making all the pulses a lot longer, so forth, so on. You got more time. You can charge those up. You know, more headroom in the capacitance value. You know, rather than 10, it's 36. And it's quite funny when I actually looked at this. Have a look down there. I took these out, and I had 1 nanofarads in there, in this area here at one stage. And when I got the detector going and just sitting at its normal, I think it was running, the crystal frequency was 1.8 megahertz. It ran perfectly, so no problem. So, you know, in some regard, these capacitor values here are not critical. But if you know, change the frequency, clock it too fast, maybe you don't want to start having big reservoir capacitors there. And if you go down in frequency, you don't have too little. So, horses for courses on that one. But yeah, I'll get this thing up and going. The other thing too, which I should mention as well, is there was at one stage early on in its life, there was an LM394 where that metal device is. That long blew up, and yeah, it took out that 4093 next to it as well. But yeah, I've cooked the board a little bit in that area. The board's not cooked, it's just a resin I used. I had to flood that 4093 with resin and apply a lot of heat to it. It just didn't want to come off the board. So I didn't want to wreck the pads, so I cooked the top of the chip, and yeah, there's a little bit of collateral heating around there. That's no big deal. The other thing too I did too, as I did the MOSFETs on the input stage, if you look down there, you can see a little black resistor. It's probably going to get blurry. Hang on, I'll tap it and see if this thing autofocuses. Anyway, there was a 20 ohm resistor. I stuck a 10 ohm resistor in there, just to be more of a match with the input resistance on the MOSFETs. You know, every little bit helps. You've got to keep that differential transistor set up there, sort of balanced, in balance, you know, roughly. It doesn't have to be, but you don't want too much of an offset going to your first op amp, which is driven by this differential transistor. Yeah, you have too much offset one way or the other, you'll start losing dynamic headroom. So keep everything close together, and you know, there's not that much movement between both. Then you basically got everything sitting around about the same position, like, you know, the same voltage levels and so forth, not one skewed off next to the, you know, positive or negative rail or something, and the other one's in the middle. You don't want stuff like that, so just match them. Yeah, shielded inductor, that's a it's only tacked on there. It's in a very bad position. But if you have a look where the leads are, where the old inductor was, it's right next to those capacitors, and I didn't want to go and shove the soldering iron down there and melt the plastic on those new capacitors. So yeah, I just extended some wires and stuck it on. Like I say, I'm just testing this out, and I'm going to refine it down. It's got a you know, a better low loss diode than the same one there, that bauble looking diode, some B, starts with a B. Well, I can't remember it. I haven't looked at it for 20 years. What is it? It's a Philips thing, I remember. It's a ceramic diode. It's 1 amp, 200 volt rated. BZ something. I can't remember the number. But yeah, I put, what are these things? These are the same as in all the GPXs and that. I think part number written onto UD3. I think from memory, what is it? It's an MUR something or other. Don't know. Anyway, same thing. It's rated at 200 volts, and they're 3 amp rated. So if you want to find those, I think either ST Electronics or who else makes them? Might be an Xperia, not sure. A lot of the components on these detectors are really old, you know. And then I look at it too and I say, look at all those resistors. That's the damping for the transmit flyback pulse, and that's actually loaded across the receive rails as well. When you're using a mono coil, yeah, I'd like to put a MOSFET in series and switch it in and out. Maybe you could do that if you could tap off some of that 4000 logic and get the timing right. You could possibly disconnect that from dampening down on the receive time period by just opening up that MOSFET, turning it off, and when it goes into the transmit cycle, just where the transmitter turns off and that back EMF pulse comes through, turn that FET on, put the series, all the resistors back in series, and dampen out that flyback pulse. And after that event, you can just switch it off again. That's what they do in all the new detectors anyway. And I think someone, God, look at this thing, it's going out of focus. Why is that? Please. Yeah, I think someone came up with a system where they're actually using the internal resistance of a MOSFET by just controlling the gate, you know, probably between 0 and about 1.5 volts or something, to have that MOSFET act as a variable resistor, right? And there's a patent on it though, I think. So I don't know how much time's on it. Might have run out by now, but anyway. Yeah, you can use the resistive element in the MOSFET to act as variable damping, and that would be really good on particular coils, because some of the coils, depending on the way they're manufactured and the shielding material and distances and you know, various levels of interwinding capacitance and capacitance to shield and all the rest of the variables, you can optimize your coil if you can optimize your damping resistor. I did that 20 years ago with these detectors, with the SD2000, and yeah, did it using a carbon pot. It wasn't the best way of doing it, but it did work. And if you went too far one way or too far the other, you blew your transmitter up. And you went too far in the opposite direction, you blew your receiver up. So, you know, if you didn't have enough damping there and a high voltage came through and avalanched the input devices, it would go straight into that LM394 and blow that to pieces, and, you know, had to go and repair it all. And it would probably blow up the 4093 that drives all that as well. So what do you do now when you can't get the LM394? Well, guess what? That metal can thing there, that comes from a ex-Soviet company, and they're based in Latvia. And if you look up Latvia and differential or log conformity transistor or something like that, you'll find that company. I can't remember the name of it. I bought a few of these devices, I don't know, God, 6 or 7 years ago. But the company still exists. So you can get LM394 equivalents. I think the LM394 has a noise figure of 0.8 nanovolt. These things might be 1. And on this detector, you wouldn't know the difference. Believe me, there's bloody enough noise. There's 10 millivolts of noise on the supply rails generated from its power supply and its, you know, switching circuitry, all that bloody digital noise making stuff there. So, yeah, there's a lot that can be done with these detectors. Complete design, redesign, you know, get rid of all that goop in there and stick a micro in it. You know, be good if you could turn the micro off and everything during the receive cycle. Oh, how do you do your samples? You know, oh dear me. Sorry, mine's going at 100 mile an hour. But yeah, that's that. How do we go from Litz wire to SD2000s? Well, don't know. I think I just got carried away. Dear. But anyway, there was something else too. Someone asked me, I think it was on Geotech. Someone asked me about, oh, hang on a sec. Yeah, someone did ask me about something, and I, damn, I said I was going to put it in the video. Hang on. I get an old dead board here. It's for a GPX, so I better squeeze this in as well. I hope he's watches long enough to get onto this, but yeah, he wanted to know some of the devices here. He showed me cooked devices. What is wrong with this thing? It doesn't want to focus. Maybe I've got my hand near it. Okay, hang on a sec. I've got to flick it around like that. Okay. Okay, here we go. I think that one there on your board is burnt. The fellow who showed me the picture. That one there is a BAV99. This one here is a 2N7002. Just a N-channel MOSFET. That reminds me, I said the wrong part number on the SD2000, didn't I? It's not a 2N7002. It's God, it's a bloody P channel. Yes, on the GPXs, you got N channel and N channel, but on the other detectors, anything beforehand, it's N channel input on the first 200 volt one, and then it's P channel. So yeah, I'll have to go and find out what transistor I put in there. God, can't remember off the top of my head. I've got drawers and drawers of damn things anyway, all similar types, but I don't know what I put in there. So yeah, anyway, that's your 2N7002. Sorry, no, that one there is a 702. Sorry, I'm not holding this in the right spot. Should be watching what I'm doing. That's a BAV99. Okay, on the other channel it's different. That there is your 2N7002, and that there is the corresponding BAV99 protection diode. All right. These four-legged things are dual gate MOSFETs. They're just whatever they are. What are they again? BF908s they are, but I put BF998s in there if I repair them, because you can't get 908s no more, but the 998s work just as well, no problem. I think one's rated for 30 milliamps, one's rated for 40, and if you have a look at the conductance curves, they're very, very similar. It doesn't make any damn difference anyway. Been there, done that multiple times. Now, we flip this thing over. All right, and on this device here, not that one, that's your damping switching transistor. That there is a 2SK1334, and so is that. And these are being phased out. They're old Hitachi devices, which Hitachi Semiconductors got turned into Renesas, however it's said. So it's Renesas. Yeah, but I've come up for a replacement for these as well. And you go, I'll tell you what, God, I could do a whole video about the input stage transistors here and on the other side of the board. And people just put in any, any particular rated 200 volt type MOSFET, and you can't, believe me, you cannot go and shove a big slug of a transistor. You can't put a TO220 type transistor there and wire it in and say, oh, look how beefy that is. No, you're going to lose so much performance. You have to use particular spec transistors or else, or MOSFETs, or else it is not going to work properly, right? So anyway, I've given you the part numbers on those things. if you can find them. God, I saw some, and it might have been DigiKey had 13, I think 13 left in stock or something, or it could have been Mouser. I'm not 100% sure. But yeah, getting hard to get. If you're going to keep your GPXs, these things blow up quite regularly, so buy yourself some and stick them in your drawer, right? That damping one there, that thing there, that's nothing. It's just a, I think it's maybe a 1 amp, 200 volt rated N-channel FET of lesser specs, or it's more beefy. It could be what is it? That's right. It's a BSP 122. I think from memory, it might be the same transistor they used on the early GPX streams instead of these. I think these were BSP 122s at one stage in the early detectors, right? And I'll give you an idea. These have a drive or gate capacitance of about 30 picofarads. The BSP 122 its gate capacitance was about 100 picofarads, and also your other capacitance across it, even reverse transfer capacitance, all sorts of things are a lot greater on the BSP 122. You can put BSP 122s in here, but you'll have degraded performance, and it's basically a fair bit of your signal coming in off your coil wants to run down the gate lead and disappear into the circuit board. That's another thing. Also, the greater the gate capacitance on these is the more noise that can be injected into the MOSFET, and that will then want to ride on your signals. It causes noise in the detector. So sometimes capacitance is your friend and sometimes it's your enemy. Okay, what else was there? There was some other transistor he had blown up on his board too. Where was it? Oh dear me. Let me think. This is all audio stuff around here anyway. It's all audio. All around here. Was it that one? I can't remember which transistor it was. But if it's that one or that one, I think both of them are just common N-channel transistors. I'll have to check up on it. I don't like just belting stuff off the top of my head on this detector. You put the wrong part in there and all hell will break loose. But yeah. I don't know even why it's got a bloody arrow and an X there. For some reason, I don't know. But this board's been kicking around. This is the one that got destroyed on a quad bike anyway. It's totally doesn't work. So yeah, anyway, that's nearly half an hour of waffle. I'll find out those parts and I'll get back to you on Geotech. But yeah, don't forget about the Litz wire, guys. If you want any, oh gee, I did zoom in, didn't I? If you want any Litz wire, there it is. Yeah, you can contact us on detectormods.com, and I can arrange Litz wire. Ship it anywhere in the world because it's flat packed. It's not that expensive to ship. But if you want a hell of a lot of it, because it's copper, it's going to get heavy. So, what does it weigh to make a coil? You're probably looking about, at maybe 250, 300 grams worth of copper wire for a coil, depending on how many turns you need, if you're making a big coil or a small coil, whatever. There's a little bit of difference in how much wire you need. I did have when I was making coils, I made up all these charts and graphs, and I don't know where they are. I've done 2 house moves, so they've probably been chucked out. Yeah, anyway, that's all, folks. I'll catch us later.